Imagine witnessing an explosion so powerful that it could wipe out an entire planet, an event so extreme that its effects were visible across the solar system. This wasn't a scene from a science fiction movie. It was a real event that unfolded before our eyes in 1994 when the comet Shoemaker-Levy 9 crashed into Jupiter, the largest planet in our solar system. This was the first time in human history that scientists observed a celestial collision of such magnitude in real time. The impact left behind massive dark scars on Jupiter, some of them larger than Earth itself. The Shoemaker-Levy 9 impact wasn't just a once-in-a-lifetime astronomical event. It was a wake-up call for humanity. It reminded us that space is far from empty and that our solar system is an active place filled with asteroids, comets, and other space debris that could one day pose a serious threat to our own planet. But how did this comet end up on a collision course with Jupiter? What did we learn from this event? And more importantly, could Earth experience a similar impact in the future? To answer these questions, we need to go back to March 1993, when a team of astronomers made an astonishing discovery. In early 1993, astronomers Carolyn Shoemaker, Eugene Shoemaker, and David Levy were conducting a routine sky survey at the Palomar Observatory in California. Their goal was to identify near-Earth objects, NEOs, asteroids and comets that could potentially cross Earth's orbit. But on March 24, 1993, they stumbled upon something completely unexpected. What they initially thought was a single comet turned out to be something much more unusual. Instead of a typical round nucleus, the object they discovered appeared to be a series of fragmented pieces strung together, resembling a string of pearls in space. This was unlike any comet seen before. The team soon realized that this object was a comet that had been torn apart by Jupiter's immense gravity. Named Shoemaker-Levy 9, this fragmented comet had been captured by Jupiter's gravity decades earlier, trapping it in an unstable orbit around the gas giant. At some point, the comet had wandered too close to Jupiter, and the planet's immense gravitational force ripped it into 21 separate pieces, each fragment now following a similar trajectory around Jupiter. But what shocked astronomers the most was their next discovery. These fragments were on a direct collision course with Jupiter. Using detailed orbital calculations, scientists confirmed that between July 16th and July 22nd, 1994, the fragments of Shoemaker-Levy 9 would plunge into Jupiter's atmosphere, creating a series of explosive impacts unlike anything ever witnessed before. This was a golden opportunity. For the first time in history, astronomers had a front-row seat to an actual planetary impact, an event that had never been directly observed in the past. When July 16, 1994 arrived, astronomers around the world, including space agencies like NASA and ESA, prepared their telescopes to witness the extraordinary event. The Hubble Space Telescope, the Galileo spacecraft, and countless ground-based observatories all turned their lenses toward Jupiter, eager to record what was about to happen. And then, it began. One by one, the fragments of Shoemaker-Levy 9 slammed into Jupiter's thick atmosphere over a period of 6 days. The impacts were nothing short of spectacular. Each fragment, some as large as 2 kilometers, 1.2 miles in diameter, struck Jupiter at speeds of 60 kilometers per second, 37 miles per second, equivalent to 216,000 kilometers per hour, 134,000 miles per hour. The result was a series of fireballs, shockwaves, and massive atmospheric disturbances that were clearly visible even from Earth. Each impact generated an explosion so intense that it released more energy than all of Earth's nuclear weapons combined. The largest explosion, caused by fragment G, released an estimated 6 million megatons of TNT, roughly 600 times more powerful than the world's total nuclear arsenal. To put this into perspective, The asteroid impact that wiped out the dinosaurs 66 million years ago is estimated to have released a similar amount of energy, but the most visually striking effect of the impact was the dark scars left on Jupiter's atmosphere. After each explosion, massive black spots remained in Jupiter's cloud layers, some of them larger than the entire planet Earth. These scars lasted for several months, serving as a haunting reminder of the sheer power of cosmic collisions. The event was a scientific goldmine. It provided an unprecedented opportunity to study planetary impacts in real time, helping scientists understand how such collisions affect planetary atmospheres, shockwave dynamics, and impact physics. The Shoemaker-Levy 9 impact was more than just an incredible astronomical spectacle. It was a crucial turning point in our understanding of planetary impacts and cosmic hazards. Here are some of the key lessons we learned from this event. Jupiter's role as a cosmic shield. The event reinforced the idea that Jupiter acts as a protective shield for Earth. Because of its immense gravity, Jupiter frequently captures or deflects comets and asteroids that might otherwise pose a threat to our planet. However, while Jupiter absorbs many impacts, it also has the potential to redirect hazardous objects toward the inner solar system, including Earth. The reality of planetary collisions. The impact proved that large celestial objects do collide with planets and will continue to do so in the future. It provided a clear, real-time example of what happens when a high-speed impactor crashes into a planetary atmosphere. A wake-up call for planetary defense, Shoemaker-Levy 9 was a major wake-up call for the scientific community and governments worldwide. It highlighted the importance of monitoring near-Earth objects, NEOs, and developing strategies for planetary defense. In response, organizations like NASA's Planetary Defense Coordination Office were established to track and mitigate potential asteroid threats. Now comes the big question. Could Earth ever be hit by a similar comet or asteroid? The answer is simple. Yes, Earth has been struck multiple times in the past, and it will happen again in the future. One of the most infamous examples is the Chicxulub asteroid impact that wiped out the dinosaurs 66 million years ago. More recently, in 2013, the Chelyabinsk meteor exploded over Russia, injuring over 1,500 people due to the powerful shockwave. While Jupiter absorbs many of the dangerous objects in space, some still slip past its gravitational influence and head toward Earth. This is why constant monitoring, early detection, and impact mitigation strategies are crucial. Projects like NASA's DART mission, which successfully altered the trajectory of an asteroid in 2022, are vital steps toward planetary defense. The impact of Shoemaker-Levy 9 on Jupiter was a spectacular cosmic event, but it was also a warning. It showed us that planetary collisions are not just ancient history, they are an ongoing reality. The difference is, unlike Jupiter, Earth is not protected by a thick atmosphere of gas that can absorb such impacts. If an asteroid or comet of similar size were to strike Earth, the consequences could be catastrophic. So, what do you think? Should humanity invest more in planetary defense? Could we one day prevent a catastrophic impact? Let's discuss in the comments below. And if you love exploring the wonders of the universe, don't forget to like, subscribe, and hit the notification bell for more mind-blowing space discoveries.